AI, robots, driverless cars, the future looks electric. But few ever ask what powers it all. The real fuel behind this revolution isn't data or algorithms, it's electricity. Every time you generate an image, run an AI model, or ask ChatGPT a question, you're using power. Just one query uses about 0.3 watt-hours, enough to light an LED for a few minutes. Now multiply that by billions of queries every single day. Add millions of data centers and you start to see it. The smarter our tech gets, the hungrier it becomes for energy. By 2030, data centers alone could double their electricity use. That's why the real foundation of the AI race isn't silicon or software, it's stable, abundant electricity. 2 decades ago, China produced only 1/3 the power the US did. Today, it generates twice as much. Wind, solar, hydro, clean energy now makes up around 1/3 of China's power mix, and it's growing faster than anywhere else. Companies like Envision, the world's largest wind turbine maker, ship tens of gigawatts of capacity every year. By 2024, wind and solar together powered nearly 20% of China's grid. Meanwhile, China is racing ahead in nuclear power too. It's building about 10 gigawatts of new nuclear capacity every year, with 28 reactors under construction, nearly half of the world's total. Nuclear gives China what renewables can't: constant, clean energy, the perfect base for a digital economy. Beijing isn't stopping there. It now runs more industrial robots than the rest of the world combined, and its factories are hungry for power. Demand is growing 4 to 5% every year. That's roughly the same as adding the electricity use of the entire European Union annually. Energy is quietly becoming the bottleneck in how fast we can scale AI, data centers, and smart factories. And here's the twist. China produces twice the energy of the US and often sells it cheaper. Chip companies in China get electricity at nearly half the cost of their American rivals. Producing power is just the first half of the equation. The other half? Moving it. Electricity often travels thousands of kilometers from remote power plants to AI-driven cities and data hubs. In 2022 alone, China poured $78 billion into building and upgrading its grid, climbing to over $90 billion by 2025. The US, by comparison, invested just $30 billion. The difference shows. China's grid can absorb surges from renewables, handle peaks without blackouts, and deliver stable power to its industries, all supported by the world's largest battery supply chain. Over 75% of global lithium-ion production happens in China. Beijing calls this transformation new productive forces, a high-tech, innovation-driven economy built on AI, robotics, and clean energy. Meanwhile, across the Pacific, US data centers are spreading like wildfire, especially in Northern Virginia. Each one can demand hundreds of megawatts, enough to power a small city. Projections show America's electricity demand could surge 25% in just 5 years and nearly 80% by 2050. But the catch? The US grid is aging. More than 70% of transmission lines are over 25 years old. China, on the other hand, has built tens of thousands of kilometers of ultra-high voltage lines, pushing over 1,000 kilovolts. In the US, most lines max out at 500. So while China's grid grows stronger, America's is reaching its limit. To keep up, the US is leaning back on fossil fuels, reopening gas and coal projects to meet AI's power appetite. But that comes with a price: higher emissions, rising costs, and fragile reliability. In some states, utilities are even canceling green energy goals and proposing new gas plants just to keep data centers running. The result? More pollution, higher bills, and an AI future that runs on fuel from the past. In this new arms race of intelligence, where chips, compute, and algorithms dominate the headlines, one quiet truth remains: the winner will be the one with the most power, literally. And on that front, China is already years ahead.